If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So today again we will be solving 5 questions starting from question number 76 to question number 80. Okay, then let's try to solve all these 5 questions. The percentage resistance and percentage reactance of 10 kVA 400 by 200 volt 3-phase transformer are 2% and 10%. Resistance 2%, reactance 10%. If the constant loss of the machine is 1%, then the maximum possible percentage efficiency of the transformer. So what is the maximum efficiency? During maximum efficiency, what happens? At maximum efficiency, your constant loss is equal to K square into copper loss, where K is the loading, how much loading you are doing. 50% load, 20% load, 10% load, 100% load, that is the basic difference of K. Okay, so because it is everything is rated, so if I go for R is equal to 0.02 per unit, so what will be my rated current is 1 per unit, because everything is on rated value. So what is my copper rate? Full load copper loss will be I square R, that is point. So it is K square, it is full load copper loss, it is 1 square into 0.02. And what is the constant loss? They have given constant loss is 1%, that is 0.01 per unit. So everything is in per unit. So K, if you do it, it is 0.707. That means this is the loading. So what will be its efficiency? So its efficiency is always at this loading you will get the maximum efficiency. So efficiency max will be equal to, what will be your output at this loading? 10 into 10 to the power 3. Your loading is 70%, that is 0.707. This is your output. 10 into 10 to the power 3 into 707. And at maximum efficiency your constant loss and copper loss both are equal. So this is constant loss, this is copper loss, so total loss. So if you do this one, you will get your answer as 97.248, which is around 97.25. That is your option B. Now if you come to in question number 77, a 400 by 100 volt 10 kVA 2 winding transformer is reconnected as an auto transformer across the switchable. The maximum ratings of this arrangement will be. So for maximum rating, this is a auto transformer. So for maximum rating, your input and output both should be high voltage, as high as you can. So what you can give, this is 400 winding, you can place here, you can place that 100 kV winding, because it was initially 400 by 100. So this 400 I kept it there, and on the top of that I place that 100. So this output will be equal to 500. Someone can think of this way also. 100 I will place here, and then 400 I will place here. So that also give you, but that will not give maximum kVA. For maximum kVA, your voltages should be, both sides should be maximum. So 400, 500, this is the maximum. Now for this type of rating, you see how much current you can push through this. Suppose current is coming from this side, so some current will flow through this side, some current will flow through this side. This is my output current. So what is the maximum current that 10 kVA can take? That much current only you can give. So if this was the winding, this I have taken this winding from this transformer. So this transformer, this winding is made in such a way so that these conditions are satisfying. So what is the I? 100 ampere coil can take, that is 100 volt coil can take 10 into 10 to the power 3 divided by 100. So that is 100 ampere. So this much current it can take 100 ampere. So what will be its kVA? 500 into 100. So one can think from this side, that is 50 kVA. You can think from this side also. What is the maximum kVA this winding can take? I 400. If I take from this side, this is your answer, okay? But one can do from this side also. So what will be maximum current here? 25 ampere. So this can take 25. So how much current is coming from this? 125. So what will be this kVA? V into I. So again 400 into 125 you do. So from both sides you will get 50 kVA. So you should be very clear. If I am using this one, then 50 into this current. If I am using this side, then this current I have to calculate, and this plus this is flowing here, not this into 400, because your input is taking 400 into 125. So this is either input in voltage into input current or output voltage into output current. So answer is 50 kVA. That is your option A. Now if you come to in question number 78, a 10 kVA 400 by 200 single phase transformer with a percentage resistance 3%, reactance 6% is supplying a current of this much resistive load. The value of the load voltage is equal to. So this is of this fashion. A load is connected of this fashion. So what is this voltage? So if I refer everything to primary side, all these impedances, so this is my load. So this is my input side 400. So 400 minus this drop will give me this current, this voltage, load voltage. If I take everything to that side, if I take all these things referred to primary. So this is my load voltage. Accordingly, then next again I have to shift it to this side, because actual is in this, I am referring to 400 volt side. So what will be my this voltage here? Suppose V load dash I am giving. This is not exact V load, because I have to convert this again to this side. if I refer that V load voltage into primary, everything is primary, then 400 minus, what is that resistance? Resistance is given 3%. So 0.03 into, what is the base? If I take for 400, it is 400 square by 10 into 10 to the power 3, that is 0.48 ohm. Similarly, X equal to 0.06 into 400 square by 10 into 10. I am referring 400, that's why I am using 400. If you refer this side, then you have to divide by 200. So if you do this one, then this is 0.96. So it will be 0.48, that's Z, plus J 0.96 into, what is the current it is taking? The load is taking 50 ampere. So if this is 50 ampere, so if you refer this side, it will be 25, because your ratio is 400 is to 200. So if voltage is increasing, current will be reduced, so it will be 25. So what will be V load dash? If you convert it into angle R theta format, that is 388.80 at an angle of minus 0.344, this much. So what will be actual V load? This is in this side. So if you again go to his original side, so original side it will be divided by half, because secondary side is half of primary. So this is referred to primary, so this divided by 2, so that is 194. So that is your option A. Two single phase transformer A and B of the following parameter. Transformer A is given 400 by 210 kVA, percentage resistance reactance are given. Transformer B 5 kVA, 400 by this, resistance and reactance are given. The two transformers connected in parallel, they share a common load of 12 kilowatt at a power factor. This determine the active and reactive power delivered by transformer A. So they have given R and X, but in their respective bases. So you have to go to common base. If I take the common base as 10 kVA, let system base as 10 kVA. Voltage is same, because both the ratings is same, 400 by 200, 400 by 200. So voltage will be same. It is also given on 400, it is also given on 400 if I take HB side as my base. But kVA will be changed. This one will be same, but here it will change. So your ZA will be remain same, that is 0.03 plus 0.04. But ZB will be equal to, ZB new will be equal to ZB old, that is 0.04 plus 0.03 J into, so it is new old, then again new is 10 kVA, old is 5, so it will be 0.08 plus 0.06 J. So now loads will be shared in the ratio of their reciprocal of Z. So if it is having high Z, it will take low load. If it is having low Z, it will take high load. So it will be inversely. So if you are calculating power shared by A, so that will be shared in the inverse ratio. So it will be ZB by ZA plus ZB, like your current division, into total power. So total power is 12, it was 12 kilowatt at 0.8. So in kVA, if you divide it, it will be 12 divided by 0.8, because I am taking complex power. So if you do this one, you put all this value, and ultimately if you divide, finally if you will get 10.045 minus 0.95 J. So this much P it is delivering, this much minus Q it is delivering, transformer A. So that is your answer. So in question number 80, a three-phase delta to star transformer is supplied 6000 volt on delta connected. The terminal voltage on the secondary side when supplying full load at 0.8 lagging power factor is this much. Okay, the equivalent resistance and reactance drops of the transformer are given this much. The turn ratio of the transformer is, okay. So this is your delta to star, this is your delta connected, this is your star connected. So your terminal voltage is given 415 when it is connected to a load of full load at 0.8 power factor lagging. Okay, so 0.8 lagging power factor. So what is this voltage E? This is your terminal voltage, because there is a voltage regulation. If you give load, the voltage will change. So for that regulation, how to calculate regulation in terms of transformer? So I think you know this formula, because your R and X all are given in per unit. So you can apply this one, R at per unit multiplied by cos phi plus X at per unit multiplied by sin a phi. It is approximately regulation is equal to this one. So if you put this value, 0.01 into cos phi is 0.8 and X per unit is 0.05. If cos phi is 0.8, then sin phi will be 0.6. So your regulation will come 3.8%. What is regulation? Regulation is no load, that is E generated, minus your terminal voltage full load divided by full load. No load minus full load by full load into 100, that is given as 3.8. From here if you calculate, it will be equal to 430.77. So this voltage. Okay. Now what is the turn ratio? Now for this turn ratio, while explaining the transformer protection, I have explained in that one. So if you take this delta now, and this is your star winding, So this voltage is transferred into this voltage. So ratio between these and this. So what is this voltage? This voltage is the line voltage. That is here 3000, 6000 is only because it is delta. Whatever line voltage this is, that becomes your phase voltage. So here across this winding 6000 is coming, but here across this winding this is not coming, because three phase voltage, if nothing is mentioned, then this means it is line voltage. So it is 430, but this voltage is not 430. This is 430.77 divided by root 3. So what is the turn ratio? 6000 is to this. This is to what is the voltage across this, what is the voltage across this, that is the turn ratio. So if you do this one, you will get the answer is nearly 24 equal to, that is your option B. If you like the video, then press the like button and please give your valuable comments in the comment section.